So we are going to prove today that a quadrilateral is a parallelogram, so it's kind of the opposite of what we were doing before. So one thing that we need to do is what's called the converse, which means basically opposite. So if both pairs of opposite sides of a quadrilateral are congruent, so this and this and this and this and this and this are congruent, then that figure is a parallelogram. So you can't say it's a parallelogram unless you know something that makes it a parallelogram or a parallelogram property. So the other thing is the opposite angles. We talked about these before. If opposite angles are congruent, this is a parallelogram because it's the converse. Okay, so let's do a couple of examples. First off, we have an amusement park ride. Sorry, the cord's getting in the way. With a moving platform attached to 4 swinging arms. The platform swings back and forth, back and forth, back and forth until it gets enough momentum to fly over the top, over the top, over the top in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms. And DC is parallel to the ground. So right here and right here, these are parallel. Explain why the moving platform AB is also always parallel to the ground. If you take a look right here, these are both equal to 16 feet. So 16 feet, 16 feet. And then you take a look right here, 38, 38. So I can say by the mere fact that because the opposite sides are congruent to each other, that this is a parallelogram. So therefore, A, B, C, D is a parallelogram. I'm just going to abbreviate here. So if it's a parallelogram, then these 2 sides here are parallel to each other. And given that this side's already parallel to the ground, that means all 3 of these are parallel to each other. AB is parallel to DC, which is parallel to the ground, which they have as line L. Okay, so you can always say it's a parallelogram. So for what values of x and y would make this a parallelogram? Use your parallelogram properties here to determine that. So I know that opposite sides, if it's a parallelogram, have to be equal. I can't just throw some random number in there and say, oh, that's a parallelogram. So 2x minus 1 equals x plus 9. Subtract the x, add the 1, and you get x equals 10. And I'm going to end up using that because here I have the opposite sides, y equal to x plus 7. So y equals x plus 7. Well, I know that's 10 because I already solved for it. So y is equal to 17. So when this is true, then this is a parallelogram. Now, if the number's off at all, not a parallelogram. Okay? So opposite sides, parallel and congruent. If you have a pair of opposite sides that are not only parallel to each other, but also congruent, you've got a parallelogram. And parallelogram diagonal converse, again, converse is the undoing of something. So if you notice that the diagonals are equal to each other through a midpoint where they cross, this is a parallelogram. So there's this doorway in England. It's kind of a crazy doorway. The doorway is shown as part of a building in England, and the building leans sideways, kind of like the Tower of Pisa, so obviously the door went with it. And you've got this crazy doorway that is leaning. So you can barely see it, but I believe this is S, T, U, and V. So why is SV congruent to TU? Why are they the same measurement? And how can you say that? Well, you can say it by the fact that these are parallel to each other and equal. The measurements didn't change, so parallel and equal measurements would mean that these are also equal measurements, even though they're leaning. So for what values of x and y is a quadrilateral parallelogram? Remember that we have to consider opposite angles being congruent. So if I wanted to solve for x and y, I would set it up as 3x minus 32 equals 2x, and I get x equals 32. And then for my y, 4y equals y plus 87. Subtract the y, divide by 3. So you get 3y equals 87, and therefore y equals 29. So for the values of x equals 32 and y equals 29, this is true because the opposites are congruent. So a couple of things. State the theorem you would use to show that the quadrilateral is a parallelogram. So you would say here that opposite sides are parallel and congruent. Opposite sides, congruency converse, and opposite angles, congruency converse. So that's the theorems that you would use to show that this is a parallelogram, or this, or this. Last problem here. Explain the reason why you would know the value of x and why you could say that's a parallelogram. Well, notice that these are equal, q and n. So if I called this a, qa is equal to an. Well, in the same regards, ma is equal to ap. So 2x is equal to 10 minus 3x. So 5x equals 10 and x equals 2. And for the value of 2, this is a parallelogram because the diagonals would bisect each other, creating equal parts. Okay, this is the review of ways that you can prove a quadrilateral as a parallelogram. Please make sure you know them, learn them, love them, all that. And if you have any questions, as always, please let me know.